Okay, while we're at it, let's look a little closer at this circuit so you can learn more. So once again, we had an 8-volt power supply. This is our positive terminal. This is our negative terminal. So positive current runs this way. It gets split here. We see that twice as much goes up here through these two resistors, as much current that goes through these two resistors, because this has half the resistance. Now, we look at this. If we go electrons, we see electrons are actually going the other way. That's the real current in circuits that have conductors. But generally, when we're teaching circuits, we use conventional current. That's an unfortunate choice of convention that goes all the way back to Benjamin Franklin, flying kites with keys on them. Anyway, but check this out. Let's learn a little bit more about this. This is kind of cool. One thing you should know is that circuit elements in parallel experience the same voltage. Now, we have an 8 volts of power supply here. So we should have 8-volt drop across here and across here. So you see there, oh, by the way, look, you can notice how I can look at the values. See that? Click the values on off. So we know what resistors we're talking about here. 2 ohm, 4 ohm, 3 ohm, and 9 ohm. Now, I'm saying that the voltage drop from here to here should be, actually, you put your red lead, you put your red lead here, your black lead here, you should get 8 volts. And you should also get 8 volts between here and here, because you're really just looking at the battery. Let me explain that. Here's a voltmeter. So if I look at the battery, notice that we should have 8 volts here, right? And look at this. Now we're going to ignore the resistance of the current meter. These are just conducting paths to these points. So it doesn't matter if when I move up here, I'm still just looking at the battery. So of course we see 8 volts across those two resistors. See that? We get an 8-volt drop across those two resistors. When I move up here, I'm still following a conducting path back to the power supply. See that? So if I move the leads up here, I can't stand that thing being over on top of it. And then I move this lead over here, we still get 8 volts, see? Now, what would be the voltage drop across just one resistor? Okay, we have 8 volts across here. We should have twice the voltage drop across this 4 ohm resistor that we do across this 2 ohm resistor. So if we have 8 volts, how many volts should I have here and how many volts should I have here? Well, one way to do it is just to know that you've got 4/3 of an amp, and you can multiply that current times the resistance. V is IR. So if you multiply 4/3 of an amp, that's 1.33. So if you multiply 4/3 times 4 ohms, you should get 5.33 volts across that 4 ohm resistor. Boom, see? Now, you've got 8 volts across these series resistors here, so if you subtract that from 8, what is that? That's 2.67. So you should get 2.67 across here. See? Boom. There you go. So that's how you do this stuff, quick and dirty. You can just do things quickly if you understand basically how resistors behave in series and parallel. What about down here? Okay. Once again, we've got 8 volts across both resistors, but we've got 3 times the resistance over here that we have here. We got 9 ohms here. So we need numbers such that we would have, 3 times the voltage drop here that you have here. However, we know our current's 0.67. So if I take 0.67, or 2 divided by 3 to be closer even, 2 divided by 3 because it's 2/3, and multiply by this resistance, 9 ohms, I should get 6 volts there. Do I? Indeed I do, 6 volts. And so what's left over? 8 minus 6, there should be 2 volts here, because the sum of those voltages has to be 8. So you have 8 volts across here and 8 volts across here. See that? 2 volts. Now, what happens if you reverse your leads? No biggie. You just get a negative number. So sometimes when I'm working on circuits and they're just DC circuits, I don't even look and see which way I'm putting the meter in. I know if I have a negative value, I'm just looking at the circuit. I'm just looking at the voltage drop the wrong way. It doesn't really matter. Anyway, there you go. I hope this helps you understand how to use this little fun tool to do some circuits if you can't solve them with math. Okay, there you go. Have a good day.